It was only after knowing the drawbacks of Rutherford's model of an atom, which was based on explaining the stability of an atom and that of the energy of an electron revolving around the nucleus. Hence, there was a need of more study on motion of a charged particles, which led to the study of electromagnetic radiation. It was James Maxwell who was the first to explain about the interaction of the charged bodies and the behavior of the electric and magnetic field on microscopic level. He suggested that when electrically charged particles moves under acceleration, electric and magnetic field are produced and transmitted. These fields are transmitted in a form of waves called as electromagnetic waves or electromagnetic radiation. This is a picturesque representation of a wave wherein from a source you find that when a charged particle moves, a magnetic and an electric field is generated perpendicular to each other. There are various terms which goes to characterize the wave like the amplitude, wavelength, crest, trough. Let us understand this term one by one. First, I shall take it to crest. The tip, the height part will be called as the crest and the depth will be called as the trough. The height of the crest and the depth of the trough is given as the amplitude of the wave. The distance between two crests or two adjacent troughs will be called as wavelength. Let us understand the same in more details. Wavelength is a distance between adjacent crests or troughs. The SI unit is meter. Next is frequency of a wave. It is the number of waves that pass through a given point in 1 second. The SI unit for this is hertz or also per second. It is the number of a wave and hence it's a number of waves per time, given time, and hence it will be having the SI unit per second and also named after a scientist, Hertz. Third is wave number. It's very simple, we understand. It makes us know about the number of wavelengths. Yes, it is the number of wavelength per unit length. Understand, it is a number of waves. So hence the SI unit is per meter. How many number of waves are there in a meter of length? So that's how we give the wave number. Let us know the properties of electromagnetic radiations. The electric and the magnetic field are perpendicular to each other and also to the direction of propagation of waves. The electromagnetic waves can move in vacuum. This is very important. Electromagnetic waves can move in vacuum. There are many types of electromagnetic radiations which differ from one another in wavelength or frequency. All these radiation constitute the electromagnetic spectrum.